Okay, so today we're going to deal with confidence intervals that are proportions. And so the first thing, if you remember from yesterday, is that a confidence interval is taking statistics plus or minus the margin of error. And if you remember, the statistic for this thing before was x bar, but today, since it's a proportion, is going to be p hat. Then we're going to take that plus or minus, and a margin of error is made up by your critical value, which we are going to figure out by, we're going to call the Z star, times your standard deviation of your sample. So that's what we're going to do today, and that's how we're going to find some of these things out. So first, let's figure out our p hat for our situation. So they said they want to know the population proportion of people that say yes. So the sample that we took, 366 said yes out of 598. So we will take the calculator and we will do 366 divided by 598. And we will get that about 61%. So our p hat, our statistic, is that 61% of the time we get what we want. We get this idea. So that's our statistic. And now we have to figure out our standard deviation. Well, we calculate our standard deviation for this by doing p times 1 minus p over n. We take the square root of that. So let's do that on our calculator. So I would do 0.61 times, well, 1 minus p would be 39%, so 0.39, divided by my n, which there was 598 that responded, and we would take that square root. So it should be pretty small. So about 0.2. Okay, now we have to find Z star. Z star is figured out by your confidence level. So we want to be 95% confident the first time. Well, if we want to be 95% confident, that means that we just want to have a confidence interval where we only have about 2.5% on both sides. Now yesterday, we just used the 95, 99.7, and 68 rule. Today we're going to use actually our table. So we're actually looking for a Z star value where we have 2.5% on each side. So let's look at a table. So if I pull up a table, we're looking for about 2.5%, and so we know that that should happen around 2. But it's actually not exactly 2, as you can see. We can get a little bit closer, and it happens right at here at 1.96. That we have 2.5% on one side, and then the other side should, since this is normal and symmetrical, the other side should be the same. So our critical value, because we want it 5% on both sides, or not on both sides, but 5% total, this area would be 2.5%. So our critical value would be 1.96. And really, like you always take the positive side, you don't really ever deal with the negative. So then we will just combine this stuff and then figure out what that would be. So that would be 0.61 plus or minus whatever 1.96 times 0.02 is. So around 0.04. So we know that, hey, like we're 95% confident that that the true mean lies between, would that be 57% and 65%. And that's at a confidence interval of 95. Now let's do the same thing for confidence interval of 99%. So everything, so this was for our 95. Let's do the exact same thing, but do it for a 99%. So everything would remain the same. It wouldn't actually change my statistic. It wouldn't actually change my one thing. The only thing it's going to change is my, Z star. So again, for that Z star, what we're going to do is we want to look here, and we want 1% total from both that. So that would be 0.5%, which when we look on our table, let's try to find that. So 0.5%. So that would be 1%. Or where are we at? Where's 0.5% on this table? Somewhere along this line, right there. In between, let's go a little higher. So negative 2.57. So as you can see right in here along this table, this is around where we have about 0.5% on each side. We could either choose probably 0.57 and we're a little bit above, or 0.58 and we're a little bit below. Let's go on the little bit above side. So that Z star value would be and we can see when we do it on a calculator, it should be a little bit wider. So it's around 5%. So really that interval would be a little bit wider, as we said 5%, so it'd be like between 56% and 66%. And we would be 99% confident that the true mean lies between that interval. So if we had to compare them, obviously the 95% is a little bit wider. So everything that we did yesterday is pretty much the same thing. Nothing else really changes except for it changes along like what you need to do. Like for the conditions to apply, if I want these things to be independent, that's that 10% rule we did before, where like you can't take samples bigger than 10%. If I want this thing to actually be normal so that I can get a good, so that we can actually do this margin of error, for it to be normal, we need n times p to be greater than 10, and n times 1 minus p to be greater than or equal to 10 also, or the population to be normal. Which a lot of times, like, you're not going to be able to figure that part out easily. So those are the two requirements that you generally need. This is how we calculate the confidence intervals today. It's pretty much the same thing yesterday, just instead of using X bar, we're going to use P hat. And instead of like being given those critical values, we're going to have to make actually some more choices. Like for getting 95 and 99, we're going to have to go and look at our Z tables and figure out like where it is half the percent we need on each side. Okay. Last quick thing that I want to show you is how we don't do this by hand. So if I don't want to have to do this by hand, there's actually a quicker way on your calculator. If you look on your stats button, you click stats, you can go over to tests. And on tests, we want to go all the way down to intervals. Now this is a Z interval, which you can do from yesterday, where you can include all the data. Or if you just include the stats, like if you include the standard deviation, the mean, and then the number of values, and then you can select the confidence interval. We aren't going to do Z's today. We're actually going to do proportions. So let's go all the way down to proportions. Click on proportion. Now we're going to put our success, which is our x's. Our success for this one was 366. The number of trials we had was 598. And our confidence level we wanted the first time was 95%. Let's see if it calculates it correctly. Oh, and look at that. 57% through 65. We got the exact same thing. Let's do it again for our 99%. So we're going to go right back there. The nice part is it stored all our data. So all we have to do is change it to, instead of 95, we'll change it to 99 and hit calculate. And there that one was too, because I think it, if I was right, yep, 56% through 66%, and we're right along there too. So today, a lot of the things, like, I want you to try to do a couple by hand, but once you get it through by hand, the calculator can do this much quicker. So I would actually just use the calculator. Try the different examples today.